Hello, welcome to this video on C# events. In this video, we're going to cover event-based programming, what that is at a high level, including publishers and subscribers. And then we'll look at how to actually invoke and subscribe to events. And we will see one of the big uses of events as being separating logic and visuals. So let's start by just seeing the big picture of why we want to use events in our game here. So the player, well, let's talk about the ending conditions. So currently the player can gain coins and lose coins, and I think I want the player to lose the game if their coin count drops below 0. So maybe I'll have them start with a certain base number of coins. Like I could do that in the coin counter here. I could say at the beginning coin count is maybe 5. And so I could make sure the visual represents that as well. So we'll say, okay, coin count starts as being 5. And every time the player hits an obstacle, we call decrease coin count. And if we go to decrease coin count, so go to definition here, then if maybe I will take away this logic about making sure the coin count can't be negative, because now I might want it to be negative. So coin count will decrease. And as soon as the coin count is negative, we'll try to lose the game. So one way I could do that is right here under coin count minus equals amount. I could say if coin count is less than 0, then we'll put a debug.log here. For now, we'll say game over, but eventually we could have some canvas reference, and we could even switch scenes, which we'll see later. So there's this place where we could put the logic here, but that's a pretty random place to have it in our code. Like, it makes sense logically to have it here, but the coin counter doesn't necessarily sound like it should be controlling the game. Actually, what we want to do with events here is, instead of saying debug.log game over, what we want to do here is fire an event saying the game is over. And in a separate part of the code, we're going to, like in a separate script altogether, we're going to listen to this event. And if we receive this event, we say, okay, the game is over, then we're going to make the game end. And so let's take a look at this diagram. It's pretty straightforward, but the idea is that the player is going to be the publisher. So the player is going to detect when the game is over and publish an event. And many others will listen to that event. So for example, we might have a script that changes scenes. It switches to a game over scene or something like that. So that's going to listen to this event so that it, when the game is over, it knows that it should do something. We'll have another subscriber that updates the scoreboard when the game is over and says the player's high score, something like that. We'll have another event that makes sure, another subscriber rather, that makes sure that the player stops moving when this event is fired. So that's the big picture here, is that you have many subscribers. They're all listening. You can think of the event publisher as being like a YouTuber who once in a while puts out a video, and many different subscribers will receive a notification and can then respond to that notification. So one publisher, many subscribers. So let's see kind of how we start to do this. So coin counter here is going to want to own this event that says the game is over. So how we define an event is we go to the very, well, I like to put them at the very top of a script, maybe up to here with the fields. And an event will usually be public because you want others to know about it. And you write event, and action is one type of event. It's one type of delegate. So action is just going to work for now. And then for naming events, it usually starts with capital O, on. You're going to say on. And then we want to describe what the event is going to be. So this one here is going to be on game over. And maybe on game over is actually a bit, it's kind of inferring that. Really what's happening is the coin count is being negative. So we could say on coin count negative, but I'll leave it as on game over. I think that's okay. So here's how we define an event on game over. Now, having this event defined doesn't do anything for us yet. What we need to do is actually say when this event gets called. And so right here is where we're going to fire the event. I'm going to say on game over. Now we're going to write question mark dot invoke and open and close some parentheses and put a semicolon. Now this is the null conditional operator. So all that's saying is if no one is listening, then this here will give us an error. But if there's a question mark here, it says if no one is listening, then don't do anything. But otherwise, you can invoke the event. So you could unpack this more. You could go look into that question mark dot. But it's a null conditional operator. It kind of looks like if on game over is not null, or it's actually saying on game over equals null question mark, then do something, and if not, then on game over dot invoke. It's going to look something like that in terms of a long form. As you can't put continue there. Anyways, so you can look into the null conditional operator if you're interested, but this is the big picture here, or this is how you write it. Okay, so far we are firing the event. Take a look at our diagram again. The publisher is publishing the event. That's on game over question mark dot invoke, right? That's publishing the event. Now what we need is subscribers to be listening to this event. So let's go make a subscriber to listen to ongameover.invoke. So let's go and make a new game object. It's going to be an empty game object in the scene. It's going to be called, we'll call it game manager. And here, even though it's not necessarily important where it is in the scene, I still want to put it at 0, 0, 0. So one way to reset that is just on the transform at the top right, click these three dots, click reset. That'll put it at 0, 0, 0, and it'll reset everything else about it too. Okay, so here's the game manager, and we need a script here that's going to listen to that event. So let's make a script. I'm going to call this script game manager as well. Okay, let's take the game manager script and attach it to the game manager game object and open up that script. Okay, I'm going to clear away the default stuff. And what we can do first of all is subscribe to the event. So we subscribe to the event one time. That's going to happen in on enable. So on enable, if you remember from earlier in the tutorial, is going to happen after awake, and it's going to happen before start. So it goes awake, then on enable, then start. So just so there's no mystery there, it does happen between those two. And that's specifically in a mono behavior. Okay, now when we enable this game object, what we want to do is subscribe to that event. So we want to say, this is in coin counter, we want to say coin counter dot and get that event, but we don't know what coin counter is. So let's get a reference to coin counter. That's one we can drag in the inspector. And so now we have a reference to this coin counter, and we can go get this on game over event. So coin counter dot on game over. And to subscribe to event, it's like you're adding to it. It's plus equals. You're adding some method in your class that's going to respond to that event. So right now I don't have anything, any method to respond with. Now, one thing that Visual Studio will give you when you write plus equals after an event, it'll give you this suggestion of a name of a method that you could subscribe with. And I think that's often a good name. If you press tab, right, it'll put in, and it'll let you rename it if you want, but it'll put in this method for you. And so it starts with coin counter, right? That's the name of the object that's firing the event. And then on game over is the event itself. So for now, let's say when the game is, like when this event is fired, let's subscribe with a method that just says debug.log game is over. Okay, so this event, this method rather, okay, is now subscribed to this event. So in coin counter, when we have on game over that gets fired, it gets fired right here. One of the responses, one of the subscribers is this method here because we wrote that in on enable. Okay, the other thing that we need to do as well is make sure that we also unsubscribe if for some reason the game manager gets disabled. So we don't necessarily expect that to happen, but whenever you have a plus equals in on enable, it's always a good practice in on disable to have minus equals. It'll save you some bugs in the long run. So there's that event. Let's test this to make sure that's working. Okay, we've reloaded. Now the game manager is looking for a coin counter. Now you might be confused. I don't see the coin counter here. Well, remember, coin counter is a script. It's a component attached to a game object. So that's actually on player. If I click on player here, see the coin counter is right there as a script. So I can actually go down to game manager and just drag the player itself and drop it there. And notice that there's a little plus up here, so I can drop it there, so I won't do it yet. If I drag a different object that doesn't have a coin counter, it actually won't let me drop it there. So it's kind of nice to us that we can only drop something that has a coin counter. So there we go, that's attached. Now let's make sure that we actually view the number of coins correctly. So I'll just go to the canvas and just make sure we set coin count. We'll start it at 3. So we'll just start at a small amount. Okay, well, we said 5 in the script, so we'll start at 5. And we have 3, and we have 1, and if we look at our console, we'll see game is over, got printed as soon as we went below 0. So that worked well. Now, was our coin count? Yeah, our coin count was updating as well there in the UI. So that looks like it worked. So that's the basics of events. You may need to look through that again, but your challenge is to create a game manager class and then to define an event called on game over in the player collision class, or rather in the coin counter class, and then to invoke on game over when the player's coin count drops below 0, and then also to subscribe to on game over event in both the game manager, so all that stuff we've done so far, but then as well to subscribe to on game over in the movement script. And I want you to make the player stop moving when the game ends. So see if you can do that. Pause the challenge and give it a try. All right, good job for trying the challenge. So what we're going to need to do in the movement script to make this to allow the movement script to subscribe to this on game over event is we're going to need to have an on enable and on disable where we actually subscribe. So first of all, let's get a reference to the coin counter. Now in movement, or rather I should just say the movement script is attached to the same game object as the coin counter. So we can just get that coin counter reference directly. So let's go private coin counter. And when we're getting a reference to another component on the same game object, we usually do that in awake because it happens right away and there's no risk of that coin counter script not being there. Sometimes you need to be aware of the order of awake and start and get some references in start. But here we can do it in awake. Say coin counter equals get component coin counter. And then I like to put awake and then followed by on enable and then followed by start, just so I remember the order here. Awake, on enable, start. But the actual order from top to bottom in this code doesn't matter in terms of these 3 methods. But it does go awake, on enable, start. So in on enable, I'm going to go coin counter plus equals. No, coin counter dot, and the name of the event was on game over. I'm going to say plus equals. And here it's giving us another suggestion. I like it. So press tab and it'll put in that suggested private method that is subscribed to this on game over. Okay, and right away let's also unsubscribe. So let's go on disable, go coin counter dot on game over, and we'll unsubscribe with the same method that we subscribed with. Okay. And now when the game ends, let's stop the player's movement. So maybe we should set the forward speed and horizontal speed to 0. That seems like one way we could do it. So let's say forward speed equals 0 and horizontal speed equals 0. That works for now. We might have to change something around later, but that seems like it should work. Let's try this out and see if it does what we want it to. That's an interesting error. See if Unity crashes. Yep. Okay. I'll be back in a moment. All right, we're back, and yeah, we just noticed as well that we actually never used the horizontal speed variable, so I guess we wouldn't really miss it, but we might as well. You probably noticed this way back in one of the early videos, but I just noticed it now, so I'll make sure we put horizontal speed in there instead of forward speed with the left-right movement, and we'll make sure horizontal speed has a decent value in the inspector, and then we'll make sure that we actually stop moving. There we go, we do. Make sure we actually stop moving when our coins go below 0. So let's see. 3. Oh, I got too many coins. Okay, try again. Hope you find that funny and not annoying. Okay. 3, and let's get a 1. And we will get... Oh, good, we stopped moving. I thought it was a bug, but we just stopped moving. So it's kind of ugly, but that's okay. It looks okay. We could also work on stopping the animation if we wanted to as well, but for now, that's okay. Okay, so that was challenge 1 for events. I want you to do some more practice for events here. So here's challenge 2. It's that I want you to try in the coin prefab, and I guess in both different types of coin prefabs, separate the coin's logic, visual, and sound effects. So early on in the tutorial series, we were looking at separating logic and visuals. So I want you to make the parent just have the logic and make 2 different children, one child having the visual and one child having the sound effects for the coin. And then in the coin class, so in the parent, in the logic, I want you to invoke an event called onCoinCollected when that coin is picked up. And then so you're going to define the event and invoke the event when the coin is picked up, and then have both the visual and the sound effects subscribe to the onCoinCollected event, and see if you can replicate the same behavior that we currently have. So I'll invite you to pause the video and try this event challenge number 2. Okay, good job trying the challenge. So let's go and take a look at our prefabs here. Now, I think if we want to make the same change in Coin-5 and Coin-10, because these are our prefab variants, we should be able to make the change in the base prefab. So let's try it and see if we can. So double click on the base prefab, and it'll feel a little bit nice, I think, to separate the logic and the visuals here, because it's kind of ugly having this collider that ends up rotating with the coin. So let's see if we can separate this. So this coin here in prefab mode is going to be the parent. Now I can make a new empty game object. I'll call it coin visual, and I'll also make a new empty game object, and I'll call it coin sound effects. Okay, and these 2 will hopefully be able to help us separate out some of these details here. So first of all, this rotate script actually only needs to apply to the coin visual, especially because the collider we have here is quite 3D. It's technically a capsule, but it's kind of a sphere. It looks spherical, and so if we just get a visual of what that looks like before we change anything while it's playing, right? In the scene, we'll go over to one of these coins. Okay, so I didn't want to actually get that coin. Let's click on this one here. Okay, notice that collider is rotating, and it doesn't really need to. That only the coin visual needs to rotate there. And so to only rotate the coin visual, right, we can take this rotate script and just attach that to the coin visual like that. So this has a rotate script on it. The coin is now a little simpler. We have a value there. Now we have this coin sound effects stuff going on in the coin script as well. So we'll have to go into that script and separate it. Let's make a new script. So this one is called coin. This one's called coin counter. That's actually on the player. Let's make a new one called coin sound effects. Okay, and we'll open that up. Okay, here's coin sound effects. So let's take a look at coin and see what we need to take over. So this scriptable object that contains an array of coin sound effects, let's actually cut that line out. So I just did a Control X to cut, and let's paste it in coin sound effects. And that's a good way of seeing what we'll need to actually move over, because we'll get an error everywhere where we need to move some code over. And as it turns out, we actually organized it pretty well. And so this play coin sound here can be taken out, and we can put that in this coin sound effects. Now this here is going to need to go in a method, and so we'll do that in a second. First of all, let's actually respond to a coin event. So let's make sure we actually fire an event. Go public event action. We'll call this on coin collected. Okay, and where we want to invoke this event is going to be right here on coin collected. We'll say $.invoke. Okay, so that's coin. This is coin sound effects. Okay, as the child, we'll go on enable. Well, first we'll need a reference to the coin. So there's private coin. We'll say coin dot on coin collected plus equals, and it'll give us the suggestion. Okay, very nice. So here's our method that gets run when the coin is collected. Let's put all these coin sound effects in that on coin collected, and we'll make sure that as well in on disable we unsubscribe. Okay, so again, this is subscribing to on coin collected event, and this one here is going to be unsubscribing. Okay, we'll need to set up some references here in the inspector. And how's our coin looking? So coin here currently has make the coin disappear. That could also go in another script. So let's actually put that in another script. I know it seems silly to put one line of code in another one, but it'll really help us in the long run to have our visuals and our logic separated. So here's coin sound effects. Let's make another script called coin visual. Okay, let's open up that script. Okay, once again, you reference to the coin. And on enable, let's subscribe to the coins event on coin collected. And here, when we collect the coin, what we're going to do is just take this mesh renderer and we will disable it. Okay, so we don't necessarily need to do anything more here. We could, cache a reference to the mesh renderer. We'll just go on disable. Okay, so we could cache a reference to the mesh renderer, but we're only using it once. If we were going to come back and use it more, I'd probably cache a reference instead of calling it right off, calling .enabled off of get component. But this is okay for now. Okay, there's one more issue in coin, which is that audio clip here, or I guess destroy depends on the audio clip length. So where is our audio clip? Well, now it's in coin sound effects. We get the audio clip from the scriptable object here. And so the question is, do we destroy the game object in this coin sound effects? And your intuition probably says, well, no, I don't want to destroy the coin in coin sound effects, because the point is to separate the logic, right? Coin sound effects is just supposed to manage the sound effects. Coin visual is just supposed to manage the visual. That's what we're doing here. Now, destroying the object is more than just a visual. That's actually a logic element. So I'd like to have that in this coin. But remember, when we destroy the game object, right? That's going to, this coin is the parent. It's on the parent. So this is going to destroy the parent, which is also going to, right, the parent here is coin. It'll also destroy the visual and the sound effect. And so really we have an issue here where we can't destroy the coin anymore. But what I'm going to do is just comment out this line for destroying. And we'll have a workaround later where we actually are able to make sure that the coin disappears and is actually destroyed. I think we'll be able to manage that later. So we'll sacrifice this one line for now in favor of having some separated logic and visuals. So our coin just has a coin script now, and all it controls is the value of the coin, and we fire this event. Coin sound effects is going to play a sound effect, and coin visual is going to manage the visual. Let's attach these scripts. So the coin visual has a rotate script, and we'll also put the coin visual script on it. And the coin sound effect is going to get the coin sound effect script. Now, for this coin sound effect scriptable object, we'll leave that blank for now. But actually, the coin we're going to get just from the parent. So you can just drag the parent directly in. So the child has a reference to the parent, and the other child will have a reference to the parent as well. Now, the reason we leave this scriptable object blank is because that is going to depend on the specific prefab variant we're in. So if I go to the coin 5 prefab variant, right, hopefully, yeah, so these visual and the sound effect, it has a reference to the parent by default. But then for the scriptable object for the sound effect, well, now I can lock the inspector here, and I can go and drag that scriptable object in here. So this is for coin 5. And now go find the inspector for coin 10. Right, so I'm in prefab mode here. Go to coin sound effect, and we'll drag coin 10 in. Okay. Let's see if everything's still working. So I'm watching my game view here. Okay, getting lots of coins there. Again, they're not. Okay, so I noticed they didn't disappear. Let's see why they're not disappearing. So in coin visual, if the coin is collected, then we should be setting mesh render.enabled equals false. And so let's see if we're actually firing this event. So, if we're responding to it. So in on coin collected, let's put a debug.log coin collected, or I guess responding to on coin collected in coin visual. Let's see if we get this message printed when we collect a coin. Okay, checking our console. Our console is down here. Okay, so we do see responding to on coin collected in coin visual. We see that there. So that's a good sign. Now oh, you know what? We're not disabling the mesh renderer because the coin visual doesn't have a mesh renderer. Right, and so let's look at our coin prefab. So the coin visual here no longer has a mesh renderer, and so it tries to get the component, but it really can't. And so it needs to go and get the coins mesh renderer. And so we actually have a reference to the coin here. Let's say coin.getComponent mesh renderer.enabled equals false. So let's get the coins mesh renderer. Okay, try that. Collect some coins. Good, they're all collected. Let's make sure the game still ends when we hit the obstacles. Excellent. So we still end up setting our player speed to 0 and saying game is over. So those are events. Make sure you go over this video again and really soak this in. We're going to see more events throughout the year. Events are going to come up quite a bit, actually. So make sure you really internalize how this stuff is working. But good job in this tutorial. We'll see you in the next one.